Good evening, my viewers. Today, we'll be talking about the empirical and molecular formula determination. In an empirical formula and molecular formula determination, in our previous video, we cited out that empirical formula shows the simplest whole number ratio, while molecular formula shows the actual number. In the video that we have been dropping, we express empirical formula as a ratio of the smallest atom present in a particular organic compound. And the molecular formula shows the actual number of each atom present. Like we likely said, that today we'll be dealing with the mathematical expression of determining the different empirical formula and molecular formula of an unknown organic compound. By a way of mathematical calculation, we will say that empirical formula E dot F will be equal to molecular formula divide by the number of atoms present. While molecular formula will be equal to the empirical formula times n, where n is the number of elements present, meaning the molecular weight of the element present there. And so in this case, apart from this expression, there are other ways of determining empirical and molecular formula. For the purpose of this class, we are going to be dealing with the three steps of determining empirical formula. Three steps. One of such steps is determining the molecular weight or the atomic weight of the individual element present. What we mean by that is the compound that actually undergoes combustion. The unknown compound constitutes or are made up of carbon, hydrogen, oxygen, sometimes metals and other, like we previously said in a previous video. Those elements present, if we can find their weight, we have gotten step one. So first of all, we look at determining the weight of each atom present, in the unknown compound. That is step number one. Determining the weight, WT means weight, of each atom present in the unknown compound. Number 2 is to determine the percentage weight of each atom present in the unknown compound. So number 1, determine the weight of each atom present. Number 2, determine the percentage of the atom present. And then finally, number 3, ratio of each atom present. Each atom present in the unknown compound. Unknown compound. All empirical formula falls into this. Some of your questions may start from 1, where you have to find the weight of each element present or each atom present, while some questions go as far as finding the percentage weight, meaning they have already given you the weight. You have the weight already of each atom present, but you don't have their percentages. So you have to find percentage. So number 1 is already solved for you, depending on the nature of the questions. Sometimes they have already given you the percentage of each atom present in your known compound. All you need to do there, of course, they have solved 1 and 2 for you. You have left it with just what? Just number 3, which is the ratio of each element present. You got to listen attentively, because in the ratio there are rules to abide with. While you get your whole number, because sometimes the number may appear in fractions, and then you needed to round them up or round them down. That will follow the rules of rounding up and rounding down numbers. So you must be careful in dealing with your ratio, especially when your ratio deals with a fraction. When fractions are involved, then you have to mind your rounding up and rounding down of numbers. So these are the basic 3 steps generally used for empirical formula determination, irrespective of the question. Anywhere you see empirical formula determination, apply this. First of all, take the weight of each atom. Look for them. Are they present? Are they giving me the weight? Do I have the weight with me? Is the weight available? If the weight is available, then you go to step number 2, which is the percentage of each atom present. And then number 3, the ratio. If you have been given the percentage of each atom present, do I have the ratio? No. So you find the ratio. So you can actually be given this way. But looking into that 3 steps, we will look at their formulas. How can we get them? There are mathematical formula of arriving at the weight of each atom. So we'll take them one after another. So according to our step number 1, there is a formula for it. So formula used in finding the weight of each atom. Number 1, atomic weight of the atom, atomic weight of the atom, all over the molecular mass, molecular or molar mass of the compound, molar mass of the compound, molar mass of the compound, times the weight of the compound. I take it again. Atomic weight of the atom or element. Atomic weight of the atom or element. Atomic weight of the atom or element. When we go into the example proper, I will be explaining this properly, one after the other. You must take note, atomic weight of the atom present all over the molar mass of the compound. For example, if I have water, water is a compound. Water has hydrogen and what? And oxygen. Water has hydrogen and oxygen. So if I want to get the empirical weight, if I want to get the weight of each atom here in water, I will say that the weight of hydrogen, for instance, weight of hydrogen all over molar mass of the compound, molar mass of water, that's the compound now, times the weight of water over 1. Weight of hydrogen all over molar mass of water times weight of water. Now, this is expected to be given in the question. Weight of water is expected to be given in the question. So it's expected that the weight of the compound has been given, meaning during the combustion, during the reaction of the unknown organic compound, after the combustion reaction, because this is normally used, the mass spectrometer, which is a destructive means of analysis, is actually used to get the weight of this compound. And so the weight of water produced from the unknown organic compound that undergoes combustion reaction, the weight of water produced is determined in an experimental way. Now, hydrogen, we know already, hydrogen in the compound has 2. So we already have 2. Of course, the weight of the molar mass of water, of course, is 18 times, of course, weight of water that will be given. When you do this, you have gotten the weight of the atom, which is hydrogen, from water. So when you do this mathematical expression, you have gotten the weight of hydrogen in the water. And so it's very important you get this. So step number 1 is very straightforward. Get your atomic weight of the atom over molar mass of the compound times weight of the compound. Atomic weight of the atom or element all over molar mass of the compound times the weight of the compound. And I have always emphasized that these are always gotten from the experiments. And so when you get this, of course, it will be given to you in the question. and then you do that, you have gotten the weight of the atom. So step number 1, we are done with that. So we'll go down to step number 2. So by step number 2, determining the weight, the percentage weight of each element present. So that is very obvious. It's easy to get. All you do is the weight you get here, meaning, of course, it's going to be weight of the atom. The weight of the atom, the one you get here, weight of the atom, weight of the atom, the one you get from number 1, divide by the weight of the compound. So weight of the compound, of course we are dealing with percentage, so that will give us 100/1. So experiment 2 or step 2, obviously we go with what you have in 1, which is the weight of the element or atom present, all over the weight of the compound, times 100/1. That will give us our number 2 step. Weight of the atom present. Alright, citing an example, you can say from here now, the weight of hydrogen is going to be weight of hydrogen all over weight of water times 100/1. This will surely give us the percentage of hydrogen in water. This will surely give us the percentage of hydrogen in water. So getting them, you don't need to dance around anything, you just need to focus and then concentrate on these 3 steps. And I bet you, there is no empirical formula question, there is no molecular formula question that you cannot handle. You handle them with ease. And that's why chemistry is a systematic steps. It takes steps. There's no magic, there's no expectation it's supposed to be this. No, it's step by step. So you go that step. So finally, our step number 3, we have to drag us to the ratio. And how do we get the ratio? It's going to be the percentage of the ratio, which is number 3. Number 3, our ratio of each element. We have to give us ratio will be percentage of the atom all over the atomic weight of the atom. Take note, not atomic, not molecular weight, atomic weight times the atom, the weight. For instance, if you take carbon, the weight of carbon there is, atomic weight is 12. So we have carbon. So if you take example for carbon, we have that. For hydrogen is 1. So it's going to be weight of the atom all over, percentage of the atom all over weight of the atom. When you do this, that's the ratio. You do this for all, this will be done for each of the atom present in your known compound. A very good point to note, all combustion reaction of organic compounds gives us CO2 and water. Complete combustion of all organic materials. Complete combustion of all organic materials no matter the size, no matter the weight, no matter the length, all combustion of organic material will produce us and give us CO2 and water. So certainly CO2 and water are product of the complete combustion reaction of organic compound. And so when an unknown organic compound undergo a combustion reaction, burning reaction, what will happen? CO2 and water is produced. And then what are the composition of CO2 and water? We have what? Carbon, hydrogen, and what? And oxygen. These are the basic composition of both CO2 and water. And so, good enough, we'll be looking at carbon, hydrogen, and oxygen. So, these steps will handle any empirical formula calculation, no matter how complex, how the storyline is being told. What you will get is these 3 steps to arrive at your destination. Your destination solely depends on your ability to take these 3 steps seriously, understood each step, what they mean and what they stand for. I bet you, empirical formula become a thing of the past. It's sealed forever. And so, hence we have known the basic steps by which we can look at empirical formula determination. We look at the examples. Now look at cite some good examples that will enable me to play around with the ratio, especially when it has to do with fractions. So we'll take a question, a good question, and then see how many questions we can be able to treat. Our questions is going to be cutting across all lines. Our question is going to be cutting across all lines, every side. Immediately you arrive at your empirical formula, your molecular formula follows suit immediately. Your molecular formula can be gotten immediately, especially if you have your relative molecular mass of the compound. So a quick one, we'll look at a very good question. Let's say question number 1.